I'm getting this error, like this error, Rust Analyzer.
Okay, it's
So I
saying
was playing with this references.
yeah, cha.
So I was trying to print the memory address, but we'll see that later. But now I have this problem.
Oh. Can you over on the uh analyze like on the red on that red stuff,
Yes.
the red like that red rust, like the error there is this particular so you don't understand what I'm saying, like this red icon here at the bottom.
Hello.
Hello, can you hear me?
Yeah.
Yeah, the rest icon, there is this red icon at the
Yeah.
bottom.
The
Yeah, that's probably where the error is. It's saying uh, let's see, you have all the
it's
options, right?
but there's no like.
Maybe we can check it later though, but it failed to run cargo metadata. Some command is failing. This is Windows. Yeah.
Yeah, I'm using WSL.
Oh, WSL. Oh, that makes sense. Yeah, I think we can start. Maybe people can join, right? Maybe those people wants to join, they can join later.
Yeah, let people in.
Yeah. So I mean, like most of us have probably like checked out some. I think we can
So,
start right now, right?
I should. Is that window? I
Yeah.
tried. I tried.
Try what Tanner Ang
I
said.
tried. Uninstalled it and installed it again,
Uh,
but it's still showing the same thing. I'll try with the new project. Let's see.
okay, okay. Yeah,
That
let's
was
let's just start. So
okay. I'm stopping.
so like how do so I'm actually thinking of quickly using the, I don't know if you guys know the Rust book. There is this Rust book which is provided by the Rust guys. So I'm either thinking of maybe we can go through that, right, like very fast, right, to actually pinpoint some important aspect of it. So I was thinking of making some presentation slide, but I was like, okay, the Rust book is already there, so we can just use it instead of just looking at the important point. Or is there any specific way you people probably want it, right? Can you guys hear me? Hello? Yeah. Okay. Okay.
Yeah. Yes, you are audible.
Yes, yes, we can hear you. Continue.
So should we like? Is there any format that you're expecting? So like, I'm just thinking of going through like the Rust and quickly pinpointing like the Rust book and pinpointing the important parts. I think that would be to be able to like to ensure that at least you'll be able to like do the assignment and to also kind of give like a very broad explanation of what's Rust like of the Rust programming language. So we can just but if there is any specific way that you guys want me to like maybe explain or something, or we can also go through the questions. I will just share my screen right now. So I'll just share my screen and basically use this particular point. We can just let's try and see if we can improve this. So I prefer to use this particular ID. It's the terminal. It's quite easier for like most of this development. So I'll probably just advise others also, if you want to like check. You should probably like start using this. It's quite easier. So basically, this is the Rust book, which is like the official documentation by the Rust, right? Rust programming language guys, and it's well detailed. It has most of the things and most of the information. There are some other like Rust resources also. Apart from this Rust book, there is I think Rustnomics. So there is also Rustnomics is like the maybe like the core the advanced level of not maybe advanced level of Rust. It's kind of explain how things work. Most of these ownership and ownership, borrowership, how they works, like how the Rust guys actually implemented them. And there is this Rustling, which is like Rust exercise. You can also check it out. There is also like learning Rust by example. Everything is on the Rust. If you check Rust channel, like everything is here. No, like Rust. So we check here. So everything is basically here, like the Rust book. Yeah, the Rust book. Yeah, this is the Rust book. I think there's also like learn Rust by example somewhere, right? So and you can easily like maybe if you're interested in building command line, if you're interested in web and networking and embed, like you can pick it. Like there are some like documentation about it. So not to like waste our time and get started with Rust. I mean, most of us probably like we have already started like going through some stuff in Rust. So this is the like just to introduce Rust, like it's basically a very interesting language, like compared to other language. It's if you are from C or from Python or TypeScript, if you are from Python, TypeScript, and all this high level language, I mean, all languages are like there's only low level language. Like if you check, like it's only just assembly and machine code, right? So, but people used to like kind of classify C++ as low level language, but it's not really a low level language, it's high level language, right? So, so basically, we see these like uh, we have the very high level language like Python, and we have the very low level language. I think Rust kind of balance everything. Like you can basically use it. It's low level. Like you can use it for system level stuff, right? You can use it to build maybe compiler. You can use it to build maybe operating systems. Some people are trying it out. You can use it for embedded and it's even from the from for something like web. You can also use it for backend. I think some people use it for front end also, like using WebAssembly. So it's a kind of very flexible language, and it's really interesting, and it kind of introduces a lot of things which is not in other language. So it's a very interesting programming language, and yeah, exactly. So I hope by now most of us already have like we have already have our tool set up. Like the Rust C is basically the compiler, right? And we have the cargo, which is kind of a tool. It's a flexible tool which is built by the Rust guys, and it's basically just allow you to do multiple things, to run to create a new project, to run your project, to run your test. So that's basically what cargo is. So like basically, I mean, most of they're like in programming language you have like some we have some language that you have to compile, and we have some language that that it's called interpreted language, right? But Rust is actually a compile language, so you have to compile the code, then get some binary. Then after getting the binary, you can then run the binary, right? So you just have to like understand that about Rust, and it's a very interesting language. The extension, if you want to create, I mean, most of us know this, so we won't be wasting time here. So if I'm going too fast or going too slow, you can just tell me so that we can move so fast or so slow. So like the extension for Rust, something like for any Rust, if you want to define a Rust file or Rust code, it's .rs, right? That's like very important. So I mean, and for function, so if you are coming from something like C++, uh, if you are coming admit. So we are just starting. Welcome Digital Online. So the idea is we are coming from something like C++. You need a main. If you are coming from so if you are coming from something like C++, you need or this is like C kind of syntax. You need to like declare a main. So this is like the entry point of your code, right? This is where the compiler is going to like start from. So but in Rust it's also similar. So there's an entry point. So you can just do so it's basically like this very simple syntax. So you have the function, and you need a main function, which is like the entry point. I mean, not all Rust file probably need an entry point like this. We talk about if you have the time we talk about it. There is a you can have two kind of files in Rust, like or two kind of libraries. So we have the binary, and we have the I think binary, and there's also other one. So I think yeah, so there is binary library, and I've forgotten the other one, but I will definitely remember. So but like if you want to write any Rust code, the main entry point is the main function, so you have to declare it. So you have to declare the admit. I think there should be a way that we can admit everyone actually. So this is the entry point, and the first thing like which we all write in most of the programming languages, we just do like how do we print to the std out. If you are from Linux guy, like how do you print out something? So this is a macro. Like whenever you see this particular sign or letter, it means that thing is a macro. So you have to understand this is not a function. Println in Rust is not a function, it's a macro. So you can also like note that. So I mean that's like the first thing you have to you have to, yeah, in any language. So uh then let me move this here. Sure, it's not moving. So basically we already like saved the file. So you can use Rust C to actually to compile it, right? So when you oh shit, I should just let me create a new folder. Okay, CF and main, right, and we can say println hello world, right? So the as I was saying, the Rust compiler, this is the Rust compiler, and it's an open source project. You can check it out. I started like going through it also. So it's an open source project. You can check it out. So if you do Rust C, it's basically generate a binary file. If you check it, I think so. It's a binary executable file, right? And you can basically like execute it, and you get your hello world. So that's just like a very simple introduction to Rust. And I mean, if you are going to, when we say the anatomy of Rust, you have to go fast and ensure that. So like I mean, most of the, because I know like some of us have probably done some programming. Has everyone done some programming language so that I can know? I think everyone must have done. You can just type or maybe React. Hello, can you hear me? Yeah, most of us have done. Uh-huh. Like, have you all done some language before? Yeah, exactly. So that I can know how fast, how slow to go. Yeah, we will definitely get to like lifetime, and we will quickly rush. Yeah, so we will definitely like quickly rush like and get to the very important aspects, lifetime and reference and borrowing. So like this is like how you create a function in Rust, and we can just move to the next. Let's see. So basically now so there is cargo. So if you want to create a Rust project, so you create it with cargo, right? So and if you want to create a new project, you say cargo new. But if it is, so let's just we say cargo new, then the name of the project. So then it's basically create a folder for your what you call directory. So then you can go to the this cargo, this particular, I don't know if we need to like explain this particular file. So this is basically like in something like JavaScript or some other languages, this is basically like package.json, where you kind of declare the package that is needed for the particular project, so that when other people needs to like come and check or do some other things, like maybe they want to like use your project, so they basically check the package, and it's basically like just to ensure compatibility. You create a project, other people want to use it, you don't want to have any kind of problem, right? That's what cargo dot .toml is for. So when you do cargo new, the name of the folder or the name of the project, it basically creates this particular file for you, right? Then you can go. Then if you want to run a project, so you can build a project by doing cargo build, right? So it basically build something similar to what the Rust C does. It basically build a binary file for you, and then you can, I think you can see the particular. So when you create a folder like that, right? When you create a project with Cargo, you do Cargo build it, build the project, and you put it inside this particular directory, if I'm not wrong, right? Then you can come here and run it. But instead of going through all those steps, so Rust is very interesting language. They already make it easy for you. So you can just do cargo run. So it's basically cargo run does the two-step, build it and then run it, right? I think one of the things I learned while learning Rust is that when you do cargo run, it doesn't like kind of run. So if you have run of multiple projects, it doesn't compile all the project again if it has compiled it initially. But if there is a new change, it's compiled that particular change, not all the particular file or something. So that's that. Then let's move to so it has this guessing project. We won't start with that. We can just, and I mean, all languages have variables, right? Rust also have variables. We won't be wasting time on that. We won't be wasting time on that, right? So basically, like, I don't know if this is where they started talking about. Okay, we just go through this very fast. It has variable, like, and one very interesting thing that you should know about Rust is that it's a kind of language that comes to like fix other language, right? So it sees the problem with maybe C, C++, with Python, then it's build a single language that comes to fix it. So we see some of it like that. So one of them is all these memory issue in C and C++. It comes to fix that. And you know, in something like Python, there is no like checking, unless you do some. I think there's a way that you can do type checking in Python, and for JavaScript, it's going to be TypeScript. So, but typing is automatically built into like Rust. So like one thing that you should know in Rust, very simple, is that by default all variables are like everything in Rust. If you are declaring a variable or maybe a function or something, everything is like you can't mutate it, right? It's immutable. So when you say something is immutable, like you can't change it. Basically, that's what it means. So if you have like and if you want to like declare a variable in Rust, it's basically you use let, something like JavaScript. Let x equals to like 5. So right, so it is that this is a variable. You are declaring a variable, but the other is when we try to like if we try to like, let's say we try to like mutate it, like let's say x is equals to 7. So even like the compiler is already like complaining, the I think the type checking Rust analyzer is already complaining that, so you can't mutate it. So if you want to mutate a variable, so you have to put the mute. So this is letting the formatter or the compiler to know that, oh, I want to like mutate this. So these are very important. So these are very though it's very small, but like the other is in many languages where you don't have something like this, sometimes maybe along the line when the code gets big, you just change some variables, and actually you don't want to change that variable, so which can lead to like bugs and stuff like that. So it's very important to note that you can't actually mutate all variables declared in Rust is immutable, but you have to printmate to be able to mutate it, right? So there's also constant, right? There's also constant, which is basically like so one interesting thing I think for constant, if you want to declare constant, you have to like using Rust kind of syntax, you have to make it like capital, like you have to capitalize it, and let's say we say 30. So one interesting thing, so I was actually making a mistake while learning this particular difference between let, constant, and mute. So because the idea is in Rust, if you have something like so you have to put the type, let's say we put 32. So let's say in Rust, like let's say we didn't put mute, it's giving error. So normally in something like in other languages, like maybe like let's say C or Python or something, when you declare a variable which is not a constant variable, you should be able to change it, right? So but if you declare it as constant variable, you won't be able to change it. But so this kind of confused me that, oh, what is this? The idea of constant variable in Rust is that you cannot change it. Like you can't put mute and change it anyhow. Like you can't change it, it's already constant. While something like x, it means like while something like if you are using let, it means you can change it. But before you can change it, you have to like by default everything is immutable. Like you can't everything is immutable. So you have to like put mute to be able to like change it if you are using let, right? If you are using let, but if you are using constant, like it means you can't change it at all, like it's unchangeable. So you have to kind of understand like that about Rust, right? Uh so so there's this concept of shadowing, right? There's this concept of shadowing in Rust, so which is also something that we have to like kind of understand. So now we said so there's a difference between shadowing and when you try to like change the variable like that. So now if I say x is equals to 6, x is equals to 3, right? So this is me like trying to I'm assigning a new value, reassigning a new value to x, right? X was 5, but now I'm reassigning the new value, which is like x is equals to 3. But there's something that we called like there's something we called shadowing. So what shadowing is doing is so we have to put mute here. So there's something called shadowing in Rust, which I can also say x is now equals to what? X plus 3. So now, like, so you have to understand that there is difference. So what is basically happening? This one is, and you see now that right now before we can actually mutate x, but like immediately at this point we can't mutate x again, right? X is like, it's like saying x is equals to x plus 3. So if I try to do like x is equals to 7, x is equals to maybe 7 now or something, I'll be getting error because we can't mutate it. But now you probably see that, oh, initially we said let x we already like put mutate that you should be able to mutate it, right? But now it's saying that you can't mutate it. So what's basically happening during shadowing is that you kind of what you are telling the compiler is that ignore this particular x, like ignore it, don't use it again. Now the new value of x is this, right? So it's like from initial one, the value of initial is x plus 3. But now you see that we have kind of changed the like ability to mutate it or not. So here we can mutate it, here we can mutate it. But now, like, so the difference between like reassigning and shadowing is that like basically is that now like you can basically change the so you can change the type also, like apart from let's say you say the type is, so this is how you kind of annotate typing, like typing in, in something like Java TypeScript. You can put type in something like C. If you want to like put the type, if you want to declare a variable, say int maybe x is equals to, so basically the x is like the int part is like the giving it a type. So you can do it in Rust also, but it's different. It's a very different syntax to C, but similar to TypeScript. So you can say let mute. So you basically put this colon and the type, so U32. So this is basically on sign or sign 32, like 32 bits of integer, right? So now in the shadowing, I can basically change the type to, like, let's say I change it to U16. So you see there is no problem, like, so that's what you can do. Like the application of this I think in this particular I don't know where they were saying it. So there is an application for this. So let me just tell you, let's say you take let's say we take a variable from the command line. Let's say I think if we say like, let's say cmd, like you take a variable from command line which is like a string, 7, right? So this is a string, right? So now instead of now declaring another like variable, like maybe you say let val, like the value of the string cmd.pass. We talk about this pass function. So what we are basically doing right now is that now, we take the value as a string from the command line, which is a string, but now we are kind of I think this pass function is basically turning into if you look at the pass function, it's basically turning it to an integer, sort of like to turn it to an integer, right? So what this is doing is basically like we have the string, you are changing it to integer. But now, so instead of doing something like this, you can basically just put cmd, like use the same cmd, so you don't have to like declare multiple variables, like you get the point. But the other is they have different type. So this is what you can do with shadowing. But now you can't make reference, you can't use this is a string down, but you can't use command line cmd as a string again. The type has already changed. So let's say I want to like say So if I want to change it to a string, so it's saying like there's a mismatch type. So you get, so because it's not the type of CMD is not a string again, right? So you should kind of understand this about shadowing. It's very important. So you can, because you can go to like some code base and see shadowing. So very different from what is this found. Hope I'm not doing some mistake here. So yeah, so that's about shadowing, right? Okay, yeah. So this is it. The other different difference between mute and shadowing is that because we are effectively creating a new variable when we use the let keyword again, we can define the type of the value, we can change the type of the value and reuse the name again. So that's what I'm saying. You take a input as a string, you take an input as a string, but you are changing it, you are changing the value to kind of maybe an hint or something. So I think that so we see more some example of it. So it's very important to note that. Let's I think there is an example of it here. Let's guess. Yeah. So let's see. So these are, because these are like basic. So uh, to ensure that where is it? Where is it? Where is it? Where is it? Read line. Oh, string dot. If I'm not able to see it, I will just move to the next one. Yeah, exactly. This is what I'm saying. Now you see that this. So basically, they are trying to like take a number, like they're trying to take a string from the command line. This guess value is a string now, but now they change it to like integer. Like the string has been changed to integer, right? It's like from string to integer. So you can use the same variable name, you can use it again and again. So that's the concept of shadowing. It's different from just mutating. Mutating is you are changing the value, but you can't change the type, and you can't change the type exactly. So for mute, but you can change the value, but you can't change the type. So let's just move, like let's continue. So we won't be wasting time here. We have like different data types in Rust, right? So for signed and unsigned integer, right? So 8 bits, you can basically define different kind of type. So 8 bits, that is 1 byte. 16 bits, that is 2 byte. 32 bit, 4 byte. 64 bit. So the difference between the two, unsigned and signed. So unsigned is that unsigned cannot have. Let's say we say this is unsigned, right? So this is unsigned. It means that if you say x minus 2, x is like it's going to be giving you error. Like you can't put unsigned. You can't put negative. That's unsigned. Sign is sign. If it is signed, which is sign. So if you save it, you won't see the error again, right? So that's that. For something like we also have like other type. We have you have the decimal, which is like the floating point. You can have different format of it. So you can also kind of like, for something like hexadecimal, you can put ox, right, to say that this is you are using hexadecimal format. So let's say ox of 5 or something. So the compiler understand it. If you are getting it as octa or binary number, you can also use a byte. So that's that. We probably like talking more about it, but like that's that about like types. We have floating point, which is basically put f32, right, instead of I or U. So floating point, that's that. We have boolean also, like true and false, right? And we have character, right? So character is just like each like character in, like if you have A, B, C, those are like character. And the difference between character and so if you are coming from Python or JavaScript, like character is going to be there is no something like character, like in everything is like some kind of string, but like in Rust or C or other language, you can, like if you have a single colon, that is a character, and let's mute y, right, that's a character. And But if it is two string, that is not a character again. That is another thing. This is a slice string, right? So we also have tuple, right? We have tuple. Tuple is just very simple, right? So this is like tuple, right? So what you are basically saying in the tuple is that this is the type. So you basically use it like this, like you put instead of is this a curly bracket? Like this is a curly bracket, right? So you can do this, like this is the tuple, right? So you put the type, that this is the type of the tuple. So the other is, I think, if you are, so let's say, just to be fast, because these are like basic aspect of the Rust itself. So we have this tuple particular. Let's say we are not giving it value now. Oh, okay, no, this is not what I want to do. So now, like, if we are defining the tuple now, but like we are like assigning value to it. So we don't need to put the type. We don't need to put the type of the tuple, right? So, but I think other way around, if you are just defining the, if you are just if you are just like kind of, you are not giving it the value, you are just declaring the variable that will, this is the variable of a tuple type. You have to put the type, you have to put type, right? You have to put type into it. And there's something which is the structuring. Most of us have probably heard it in languages like I think it's in JavaScript. It's in JavaScript. So this is also very important. You see it a lot in Rust. So there is something that you can do, destructuring. So I will just explain it right now. I also want to be conscious of the time also, right? So basically now we have tuple, which is of 3 types. So instead of saying how do you access a tuple, like if you want to get the first value of a tuple, second value, and third value, so you basically say like tup of 0, of 1, of 2, and of 3, right? So this is how you access the value. This should give some error because there is no 3. It starts from 0, so it's 0 based, 0 1 2, 0 1 2. So here we have like 3 values, so that's 0 1 2. So I can basically say let x be tup dot 0, right? But and then say and you so I can then now say pp. Then I can say this, so but instead of wasting the time, so just do the structuring, like just give the value, so we just put it into the bracket xyz. So what is going to happen is that if we try to print it, if we try to print let's see, and so if you want to print something in you want to print the variable in Rust, you can do it like this. You basically put a bracket into the print statement, right? And if you do, let's say we do cargo run, so we get the value of 500 for x, right? 6.4 and 1. So this is basically the structuring. You see this pattern we can do it for array also, right? But when we get there, so we also have the array type, which is basically the normal array type that most of us probably know. So this is the array type, right? This is the array type. We are saying let A be equals to all this, right? And so some things that you should know about array. If you are coming from something like JavaScript or Python, you can basically say I think a dot push or something for array, like in JavaScript or Python, push, and I think I've forgotten the function or the method. But in Rust, like array is like a fixed size. You can't change the size, right? You can't change the size. So that's very important. So this is like 1 2 3 4 5. So you can't change the size, and they also have to be like, hello, yeah, someone is, yeah, talk, Sinan.
Hello?
Yeah, I can hear you.
Can you hear me?
Yeah, I can hear you.
Please, I'm having network problem from my end. Can you please come back?
Can I what?
Can you please come back, small?
Okay, like I should say it again.
Yes.
Okay. So from the tuple, right? Yeah, so basically, like I mean I already talked, like, so like there are like different types in Rust, right? So like there's like the simple type, like the basic type, right? There's the float, there is the integer, there is the boolean 0 and 1, and there is the character. So it's very important to understand character. So it's just like so when you see single quote, that's like character. So if you are coming from Python or JavaScript, single quote and double quote is strange. Like it's all strange, but it's very important to differentiate. When you see single character in Rust, that is a character. In C plus plus also single character is that's single quotes, that's a character. Or something like string always have double quotes. But in Rust, string is kind of more complex. So it's not just when you see double quotes, it doesn't mean it can be different kind of string, but it's a string most of the time. So then we have something called tuple, right? So tuple, they call it compound types. So it means they can have like multiple values, right? So sorry, it can have multiple members, right? So inside a tuple, this is the tuple now. Like we are declaring a tuple. So if you want to put sign in the tuple, like if you want to put the sign, so you can say I32 F64, like to say this is a floating point, and you hit. So what is the difference between I and you? When you see you, it means it is unsigned, right? You can't have negative, it's only positive. And if you see sign, if you see I, it means it can be signed. It means it can be negative, it can be positive. So maybe if you are from JavaScript, for some people that are from Rust, from C++, they might be able to understand the difference clearly. But like simply the difference is that when you have something like I32, which is a sign, it means it has sign. It has a sign. So it means so you can have like negative and positive, but for something that is U32, which is unsigned, you can only have positive value. So there is a particular range that you can know that you can. There is a particular formula for knowing the range of if something is, if it is signed, like what are the values that it can represent. Because something like I32, what I32 can represent, U32 might be giving wrong stuff like that. It might not be able to represent it. But in Rust, I think there's a way they did it. But like there's a particular formula if I can still remember. So if something is signed, it means it's negative. I think it's from if someone also like kind of remember the formula 2 raised to power n. I think it's 2 raised to power n 2 raised to power n minus 1 minus 2 raised to power n, then to I think then to this particular value 2 raised to power I will kind of explain what this means. 2 raised to power n, I think minus. Hello? Yeah, talk. Sinan? Maybe that was a mistake. So 2 raised to power n minus, I think minus 1. So there is this part. Let me just search. I've forgotten formula for. We can use ChatGPT here. So this is very important to know, right? So formula for signed and unsigned. Make it short, bro. Oh shit, this is bringing some complex. What is this? Exactly. So this is what I'm saying. So now, like for something that is on for signed,
Oh, this is the range.
yeah, this is the range. Exactly. Thank you very much. This is the range. So for something that is unsigned, so it's from 0 to 2n minus 1. So it can represent more positive number, right? Signed. While unsigned, it can represent some negative number to like positive number, but it won't be able to represent bigger positive number. So that's the difference. You can look into it more. But that is the basic difference. So let's quickly move. There are some things that I might miss, but we can move. Array, we already talked about array. It's fixed length. That's, you should know about array. That is fixed length. You can have like multiple length, right? It's fixed length, right? So and
Hey, Usman, yeah, can we put a more number to the right in the tuples?
can we what?
Can we put more number to the right in the tuples?
More
Tuples,
numbers
tuples,
like
yes. Yeah, you have three. You have only put three numbers, right? Can we put more like five, 6?
Yeah, you can put more numbers. You can put
So
thousand.
it has to. So it has no. So it has to be this type only in the left.
Yeah, so it has to be like the same. So this is like type
I'm
int.
saying add one number to the right.
No, if there will be error, there will be error. So it has, you see, mismatch type. So this is like it has to be the same. So you are declaring it like with
Okay.
it has to be
For every number we have to declare the type. Okay.
so it the idea is, see, you don't need to like declare the type if you are giving the value. Let's say like you do it like this. So Rust will automatically infer the type, right? You see there is no error. So because this is like this is expecting let's just remove this also. So you see there is no error. Rust will automatically infer the type by itself, like if you don't put the type. But if you put the type, it seems that you are specifically telling Rust that okay, you are expecting uh one two like like you already make it to be fixed, right? So if you are putting the type, right, if you put three types.
Sorry to interrupt. Hey everyone. Hi. Hello.
Hello Ashish.
Yeah. Are you recording this video?
Yeah, I'm recording it also.
Okay, sure. Thanks.
Yeah, yeah,
Carry on. Carry on, please.
yeah, we'll try. So that's basically about tuple. So for array also, so you can basically, so if you declare an array like this, so you are telling it that okay, you need five length of five, and so five lengths, right? Array of five lengths with three, like each of the elements should be three, like right? Each of the, so this is how you give a type to. Let's come here. This is how you give a type to an array. So what you're basically saying now is that this is an array of type signed 32-bit integer, right? With five lengths, right? So if you add more than five lengths here, you can look at the syntax more, but like just try. So if you put more numbers here, there will be error, right? Because you already say it's five lengths. It's of five lengths. It's the type is I32. So if you try and put something like maybe character, you should be getting some error. So mismatch type, right? So when you put the type, you can't change it. And something that's very important between if you are from JavaScript or Python, in JavaScript it's you can actually add more, like in JavaScript you can have different types in array, but in Rust you can have different types. It has to be the same type, right? So you have to know that about array. So let's quickly move. We have already talked about array, and accessing array is just like the normal way that we access other variable, right? So if you want to access an array, like in other language, so you just put bracket. This is the first element, so right. So and second element, third element, like that. So we can move. So functions are very so we already like functions. We already know functions in other language. So let's so we can basically like declare other kind of functions. Fn, let's say print, right? When you print, you can say, so you basically have a function that is printing. Then you can do whatever you want to do. Hello world. So one thing which is very important in Rust is that if you look at it, you can basically put the function below or above, right? You don't need to put it above the main. In something like maybe other languages, you have to put the function above, but like in Rust, you don't need to like put the function like above or below. So it's kind of hoisted, like they call it hoisted in JavaScript. Or you get like you can have access to the function. So if I say print, if I call the function print, it will still work, right? It will still work. So we do cargo run. So you will get hello world. These are like warnings, like because I'm not so these are just warnings, like it gives you warnings sometimes because I'm not using some of the variables, so like I'm not using it, so it's
Type that on terminal, bro.
eh
Type that on terminal. Yeah.
what yeah this is the
You're
terminal.
getting sorry. Okay.
Yeah, this is the terminal. So that's so like how do you type if so, let's say like our print function is taking a variable, it's taking argument, so we can have a, you put the type 32, then b, you can put maybe it's taking any, maybe u32, so it's ensure that, you see, it's already complaining that I'm not passing a variable. So, and also if you want to do return type, you put something like this. This is what is, I think this is similar to Python. So you put a return type of, let's say it you can say u32, right? It's, say u32, it's returning type of u32. Then we can say you can say maybe 3 comma, so 3 comma 4, right? So this is going to work, right? So it's saying, okay, so interesting. So now you will see that we are not returning anything. So let's talk about returning stuff in Rust. So right now it's saying found this particular, it's called unit, this, I think, maybe is it, I think this is called unit tuple. Yeah, this is a unit tuple because it doesn't have anything. Yeah, this is a unit tuple. So automatically when you declare a function in Rust, and you declare any kind of function, automatically it will be returning this particular value, right? This is unit struct, it means it's empty automatically. So but now we are saying we are expecting u32, but we are not returning anything anyway. So in Rust, if you want to return something, so you can just put the value, like you just put the value. You don't need to put the return statement. If you do this also, it's going to work. But you will see, like most of the Rust syntax, most of the Rust code, you'll be saying something like this. This is returning value, so they won't be putting return. So you should take note about that. So even if you have something like let's say we have a character here, so this will give some error. So it's expecting character we are putting. So you can just return a character and say, let's see e, right? So that's right. So that's that about return type and in function. So we already talked about the parameter, we already talked about all these things. Yep. So I mean, one interesting thing about Rust is that you can have something like this, right? You can have something like this. You can have something like this particular block. So we are not putting this is expected. So you can basically initiate like this, right? You can basically put the value like this, like you can basically declare a value like this. So let x because 3x plus 1, so it's returning x plus 1, right? So you don't need to put something like return here. You don't need to put return, you don't need to put return. So automatically this is going to be putting x plus 1. So you have to remove this. Yeah, that's that about function in Rust. It's because we are fast. Comment, just this type, this is comment. So I think there is also like some kind of other comments, which is like for Rust doc. If you are writing documentation in Rust, so it has, you can put 3, but like normally it's just 2. So now like control flow, it's just like normal like control flow in other languages, right? So like we have for loop, we have while loop, right? And in Rust we also have something we call this particular syntax, which is what this means is that just keep looping. This is not in another language, right? You can, of course, you can do it in another language, like just looping without stopping. Like Rust have a particular syntax like this. So let's say we say print hello world. So this is very interesting. You can say if you have, let me just remove this. If you have something like let a be equals to 5, right? So we can let's just use so if else statement, just like normal if else statement. If let's say if a is less than 0, so we can say break, right? We can just break from this. So you can use break statement. So this loop continue looping. So we can have something like this. Then we can kind of decrement. I don't know if this Rust is. Oh, they don't use this. Okay, they don't have something like this in Rust. Okay. A is because I think it's something like this. Posts. Okay, So let's just a is equals to a minus 1. So it's going to give you some error. Why is it giving us error? Because we can't mutate a variable. Just put mute here. So right, so we can then keep printing the value of a, right? So now if you try to run it, cargo run. So what you expect, loop, it keeps looping. It checks if a is less than 0, which is like, that is the control flow, like checking a. So one thing, you don't need to put brackets, like in maybe some other language you have to put bracket, but you don't need to put it in Rust. You don't unnecessary. So it's saying unnecessary, you don't need to put. So if you run it now, cargo run. So we get the value, right? It's print out the value. So that's just that's the loop statement and if. So we also have something like we also have for loop, right? So if
Try fixing the print statement. The print
eh?
statement is fix the print statement. The A should be outside of that bracket, curly bracket. In the
Yeah,
next, yeah, as an argument. That no.
what are you saying?
The print statement.
Yeah.
Paste it. Yeah, the A inside that bracket should be outside as a
Yeah,
second parameter.
yeah, it can be outside, it can be inside, right? So
Yeah, it's inside. That's why it's giving error, I guess.
no. That is that the reason? No, it's not giving error. This is just I
It's
mean,
also valid.
this is just the UI. I don't know why it's is it the reason why it's
Oh,
giving error? No,
okay.
it's you can have it like it's just the way my you can have
So
it.
that's also valid. Same.
Yeah, both of
Okay.
them are valid. So, but there will be sometimes where it won't be valid. Where I think if you have something,
Okay.
if you have some very, maybe we see it. So there are some things that you have to put it here. Like you have to put it here. So sometimes we put it here. Let's see if we put exactly. So let's see. So exactly. So it won't be valid in some scenario like this, right? When you have some expression, if you want to like do some operations, right? So like the earlier it's just a value, you're just putting the a value. But if you are doing some operations, so you just have to put it here, right? If you are doing some operations, so it's going to work here. But if you put it inside, it's not going to work. So that's the only difference. So maybe it's just better to just do it like this, since if you keep putting it inside, it gives some error. But it basically works if, if, and else, right? Just like normal other languages, like so in maybe in something like Python it's elif, but in Rust it's else if, so and then s. So take note of that. Let's move. Then we also have, yeah, you can also do it like this, right? So let's see this syntax. So you can also have something like this, right? You can just copy everything and so you can basically have something like, I think this is, we also have something like ternary operator. Exactly, in Python and JavaScript there is some ternary, even in C, in C++ there is ternary operator. So what we are basically saying right now is that if the condition is true, so when you have a block, so this is like returning. Don't forget in Rust, when you have something and you are not putting semicolon, that is return. So it's saying if the condition is true, return this, right? S return 6. So you should kind of be familiar with this syntax. We see more of it. So this is what this is doing, right? So that's that. So one important thing is if you are returning. So if you are returning 5 here, this is like unsigned maybe 32. I think by default, if you write a number, it's on side 32, right? It's on side 32 in Rust. So if you now return something like this, there will be error. Maybe you are trying to return something like this, right? So there is going to be error. So because the error is now, so there is a conflicting type. So earlier before, Rust was able to like infer the type that okay, the type of number is U32, right? Unsigned 8 of 32 bit. But now you are saying if you now put something like this now, so Rust is not able to infer. So you are saying this is it can take unsigned, and it can also take string. So you can't do it like that. So Rust is not able to infer. So that's why it's giving this particular error. So you have to like it has to return the same type, right? So that is also like that. We have already talked about loop. We have talked about loop. So this is also very important. So like earlier before, you can also like assign the value of a loop to a variable. So you just do break. When you do break the value, you put the number that you want to return, right, at the front. This is, it means that after all this operation, if the counter is 10, so you come into the loop, you are incrementing the value of counter by 1 every time. So you say if the counter is 10, right, it comes into this particular, it comes inside the bracket. Then you are saying break this loop. You break the loop, then you say counter multiply by 2, you return counter multiply by 2. So this is a particular syntax you can see somewhere. So, and it's also very kind of important that this loop is like, it's going to loop continuously. So you have to kind of have this kind of logic that breaks out of the loop, right? So yeah, breaks out of the loop. Yeah, this is like having multiple loops. Like if you can have loop inside loop, right? So you can have loop inside loop. So the other is, so if you have loop inside loop, so if you have a loop inside a loop, so if you just put a break statement like anywhere, it's going to return out of all the loop, right? It's going to like return, out of the loop. But if you kind of put this particular, I think this is lifetime. This is probably a lifetime, or a way of just saying that. Okay, they call it loop label. This is not lifetime, but this is how you kind of also do something like lifetime also, which hopefully we should talk about. I will quickly move fast. So if you have a loop with loop, break and continue. Okay, sorry. So if you have a loop, if you have two loops, right? So if you have one loop inside the just like normal other languages, right? You have two loops. So if you do break inside one loop, so it's going to return out of the inside loop. It's not going to return out of the outside loop, right? So but you can kind of label it and say this break, it shouldn't return out of this loop, it should return out of the, like it should return out of the outmost loop, like this particular loop. So this break, if this condition is satisfied, this break will return out of the inner loop. But if you look at this particular break, it's there is a loop label that, okay, this is this loop, this break is for the outmost loop, right? So when it's break here, it's return out of the outmost loop. Like, so you should, this might be useful. I've not used it before. Yeah, nested loop in JavaScript, exactly. So when you have it's something similar also in Rust, but the other is, in all other nested loops in JavaScript and other languages, when you do break statement inside the inner loop, it's only return only inside the inner loop, so it will return outside the inner loop, right? So but the other now is that if you now have two loops, but you want to so if a condition is met, you want to return also outside the inner loop, like you want to break the outermost loop. So you have to kind of put the label that, oh, this break statement is not for the inner loop, so this is the label, it's for the outermost loop. So that's what this is trying to say. So we also have while statements, similar to like if statement, right? While statement is there, right? We also have for loop. If you are if it's very important, if you are in something like Java Python, this looks like some Python syntax. You kind of say, okay, A for elements in A. So this is like element is just basically all the elements in A. So it just print all the elements, right? So that's what for loop is, right? And you can kind of say, so I think you can say something like a slice one dot. So you can put like just wait. I think you can do something like this. Yeah. So now, like, what I want to do right now is that I will talk about this particular operator later. So what I want to do is that I want to print from 1 to this is 1 to 2 exactly. So this basically, but it's not going to print just like other languages. When you start from, if you say maybe in Python for I in range of something like this is Python 0 to 4. So it's not going to like add this particular element. So like this is not inclusive. So 0 to like 2. It's going to print 0 to 2. So something like that also. So this is basically called slice. We talk about this, right? So you can also do something like this, right? So instead of doing something like this, we can do something like this, right? So stuff like from 1 to 2, right? So this is going to be the index. So let's say you know the length. Let's say the length len of a, because len, you know the length of a. So you want to print out the element, you can just say from 0 to len, right? So from 0 to len. Then if you do cargo run, so it basically printed everywhere. So all these errors is because we are not using some values, like they are warnings, like they are not errors. So it's just the syntax analyzer is just telling me that, oh, I declare a number, I'm not using it. Okay, so now like this is like I mean, like if you are not going to get anything outside of this class or whatever we have been saying, this is like very, very important. Like the idea of ownership and borrow in Rust, it's like the most, like I think it's like I'll probably say it's the most important concept. Like one of, maybe not the most important concept, but like one of the most important concepts in Rust. So if you're not going to get anything from here, you should basically you should be able to like we are not going to move. Like this is like very important that we probably use some time, like just understanding ownership and ownership and reference. Ownership and borrowing, like in Rust. So reference also, they use reference for borrowing. So you have to understand, because there are some other concepts that you meet later that it's, you'll be like, what is all this? What is all this? So if you don't understand the idea of ownership and borrowing, so I will try and simplify it in how I understand. So if you are coming from a language like JavaScript or Python, most of the time they don't really tell you about, they don't kind of emphasize on the something we call stack and heap. Something we call stack and heap. They don't talk about this much, but if you are coming from C++, they always talk about these particular two things every time. Like it's very important. So these two things is very important for you to understand, like the idea of ownership and borrowing in Rust. So I'll basically just like kind of explain it, right? So when you have some simple type, so for something like C, like when you're writing all these things, when you're writing all this language, for simple type, okay, let's do it like this. So basically there are some variables that you can have inside the stack, and there are some variables that you can have inside the heap, right? Like when you're writing your programs, there are some variables that are stored in the stack, there are some variables that are stored in the heap, right? So you should that, right? So in something like C++, you can basically say, okay, I have this variable, I want to store it on the heap. Like heap is something, they call it dynamic memory. Like you can basically allocate anything you want on the heap. Like you can basically say it's using like through programming, like in C, they call it memory allocation. So you can, something like C, you can say int star p is equals to malloc or something like that, like the size of int. So what we are trying to say here, is this going to work? No, it's not going to work. This is C. So but what we are trying to say is that this particular variable is a pointer that is, don't let us talk about pointer, don't let us spoil everything. But what I'm trying to say is that allocate a memory of 4 bytes in the heap, and the size has to be the size of ints, right? So let's say if it is in Rust, we say U32. So U32 is like I already talked about it. So we are saying, okay, in the heap, allocate a memory of what? U32 in the heap. You can do it as a programmer in C++. That's what we are saying with this particular syntax. Allocate this particular memory in the heap, right? But the other is in C++, whenever you allocate something like this, you have to kind of clean it. So so right now when you allocate the memory, you are saying, okay, the pointer to the memory, like what you can use to access that value in the memory is this p. That's what we are just saying. Allocate a memory in the heap, and let p point to that memory. That is the concept of pointer. Like if all this is just, that's like the basic concept of pointer. So you can go out there and say you already understand pointer. So you are saying allocate the memory in the heap of size U32, which is like 4 bytes, and let P point to it in the heap. So you can do this manually in C and C++. You can do it in Rust also, but like that's not the idea of Rust. Like I think in unsafe Rust you can do it, but like that's basically what how to allocate memory in the heap. You can do it manually in C. But now you now kind of come here now that okay, so whenever you allocate the memory in the heap, you have to clean the memory. That's the point. You are the one that allocate the memory. You have to clean it. So in C, you have to do something like free P. So what you are saying is that this memory I allocated it in the heap. After using it for some things, free it. You have to free it. But now there comes the problem in most language, in something like C++, like which they call all these memory problems, and this is like one of the major problems in C world system, all these like any software that use C or C++. So now the other is so whenever you free a memory, you can't free it again. Like it's already free, like you already cleaned the memory up in the heap. So there will be like some syntax error too, like some error that you now go and free it again in C that we already free P, but like maybe after writing it you forget that you free it somewhere, then you free it again. That's what you already free some in memory. Why are you freeing it again? So that's a problem. Also, like apart from the fact that you already free it, you can also like in C. So when you free it, let's say in another part of the program, you are not using the value again. Like you're not using P again. Like no, let us just say print the value of P. This is not how the syntax works, but like just to explain, I think it's probably printf and all this kind of stuff. So what you're not saying is that print the value of P, but the other is you allocate the memory on the heap, you already use it for something, you already free the value, but you're not printing it. Or maybe you are assigning the value to something else. But the problem is you already free the memory. Like that value that you're expecting in that heap is not there already. So you already free it. So if you are doing something like if you are trying to like allocate it to something else, that is like some problem. Something about C is that C is not going to tell you it's a problem because the other is you already free it, but there may be some garbage values. Like if you try to print it or try to like allocate it to another particular value, there will be some garbage value. That garbage value will be assigned to the value that you are trying to assign it to. But like C won't tell you it's a problem. It's just going to go on. So you will know that your program is doing nonsense, right? So because that's how C works. C ensure that you have to take care of all those things. So in something like C, if you want to, you have to check and ensure that maybe you have to say if P is not null, if P is not empty, right? If P is not null, do this because you want to ensure that P has not been freed or something. So now, and also like another problem is you can also have like this is what they call dangling pointer. Like the pointer is not pointing to anything, but you are using it. The pointer is it's already like freed, right? The pointer is already freed. Why are you still using the pointer again? So it's pointing to like nothing. Like exactly. It's is this dangling? No, I think this is not dangling. I think dangling is so basically for dangling. Let's say you have a function now. You have a function. Yeah, I think this is dangling pointer. It's not pointing to anything. It's just a pointer that is not pointing to anything, but you are using it. So all these things, these are the things that lead to like security vulnerability, right? So, like they kind of cause problems. So just understand that in C++, when you create a memory in the heap, you have to free it. But if you are not freeing it, or you are freeing it 2 times, you get your memory is doing nonsense. You have problems. Some people can use. There's a particular security attacks that they can use that for. So some people can attack your program, or your program can keep running and it will lead to like segmentation faults where you're trying to like access a memory that is already freed. So all those kind of errors. So that's the problem with something like C, about like something like that. But something like Python and JavaScript, the idea is they don't need you to like allocate memory. They do it for you. But the idea is how do they clean the memory? So they have a software which they call garbage collector. So what garbage collector does is that it's a software that basically go through like whenever you're running your Python, JavaScript code, all these high level languages, this garbage collector basically go through the memory and see there's a way that they do it, and it basically go through the memory, see if the memory, if there are some pointers that are not used again, then it's clean it, right? So that's how garbage collector works. Instead of you cleaning it manually, all the memory, this is only for the heap, you have to understand that. So it goes through the heap, see the memory that are not being used, it remove it automatically for you. This is like part of the maybe JavaScript just in time compiler or their interpreter or Python, right? So it's there. But the problem with this software is that so it makes JavaScript and Python to be slow, right? So it basically go through the E every time. Maybe you don't know, you are not noticing it, but it's a software that is also running with whenever your program is running. So it basically go clean, it does all the work all the time. So it makes your program to be slow, right? So from the C side, you can have problems when you did not free your memory, or when there is when you are not freeing your memory or memory leak. So the other of memory leak is that, let's say after doing this, something like this, you are not freeing the memory, right? You did not free the memory, and you start having all this kind of maybe you allocate a lot of memory. This is just a very small size. You might be allocating a lot of memory. There are some softwares, there are some things, there are some places where when you keep allocating the memory is going to be used up, right? Like at a point the memory will be used up. You are not freeing it. If you have a very big software, you are allocating the memory, you are not freeing it. What happens is there will be like memory leak because you are not freeing the memory. So it can lead to like when your software will run out of memory or something like that. So this might not be in very big application, like this might not be very important. This is very important, but like you might not be able to see the effect of memory leak. But like the other is, you have some soft, like maybe you are doing some embedded stuff that they don't have a lot of memory. Imagine you are doing something like ESP32, this Raspberry Pi, they have little memory, so you have to free, and you are doing some work, so you have to free this memory. Apart from that, other guys like some cyber security guys, all these hackers, they can use the memory leak to attack your system. So those are the problems. So if from the C++ side, you can actually allocate the memory on the heap yourself, but the problem is you can have all this cybersecurity, all these vulnerability, all these things that we are talking to. You can be printing something that has already been free. You can have dark pointers, but from something like high-level language like Python and JavaScript, the problem is that this particular Python and Java, when you have something like Python and JavaScript, it's slow, right? Due to the garbage collector going to the heap and trying to like free the memory. So that's the problem. So Rust is trying to solve that with borrowing and ownership. So, and before we talk about borrowing and ownership, I don't know what I said, what I just explained about it, if it is clear, I mean maybe a little clear, or if there is any question. Hello, guys.
Hello, please can you hear me?
Yeah, I can hear you.
For me, from my end, I'm having network problem. So please, can you please come back again?
Okay.
Just in brief.
Okay, briefly. So
Yes.
So in something like C++, or in every programming language, there are some values that are stored in the heap, and there are some values that are let's I think we should talk about that also. I was going to talk about that, but let's just do it simply. So in every programming language, there are some values that are stored in the stack, and there are some values that are stored in the heap, right? So you have to know that in every programming language, there are some values. Yeah, sort of, it's recorded, right? So in every programming language, there are some values that are stored in the heap, there are some values that are stored on the stack. So you have to know that in some all the basic values, they are stored in the stack. So all the basic values, they are stored in the stack. What basically happens is that like the stack automatically free the memory itself. Like the stack itself is very easy. So that's also like some things that we need to explain about the stack itself. It's very simple that if you have let's say you have a function A, something like this, function A doing something, and it has some variable, it has some value, and it also has some something like this, right? Maybe some value, or it's returning some value, or just printing out some value, right? Or let's say it's declared some value and it's also printing out some value. Let's say it has some value, like the function has some value. So so how the stack works is that whenever you have this main program, like all your functions are being pushed on the stack. You can go and learn more about that also. But like very simply, you have something like A. Let's say we now call A many times. Like A, you call A, you call A again, right? So you call A 2 times. So what basically happened in the first time, you're going to have a stack, right? So you are going to have a stack. The value of A will be pushed on the stack. So everything, like even I think the first thing you have to know is that in programming, like any programming, if you are writing Python or something or any kind of programming, so this main function, the entry point, the main first function is pushed on the stack, right? So then the programs keep reading. So when it gets to this A1, let's call this A1, let's call this A2, it pushed this also on the stack. After that, it pushed this also on the stack. So what you need to understand about stack is that stack is like first in, last out. I don't know if you have the time to explain all this, but I think it's very important. Even if you stop at this particular, if you're not able to like go on, if it is this ownership and borrowership that you understand, let's search for a stack picture. Programming. Let's just use this particular. Let's use this particular simple diagram. So let's use this particular simple diagram. See now, let's say we're writing a particular program. This is A. A is like so in all this what these things are doing behind. What all these like whenever you're writing code or something, what they are doing behind is for them to be able to maintain anything. So they are using stuff for it. So we can also like go and learn more about it, but like just to be able to understand what you're saying. So they have this particular stack. What basically happened is this is the main function, the entry point, the main function. All the variables, everything of the main function is inside the function. Like if you have A, if you have B, if you declare some variable, right? So they are all inside this particular stack. The stack, they are all inside this particular A. So now let's say now this A now call another function B. So the B will also be pushed in the stack. Let's say function B now call another function C. The C will also be pushed on the stack. So this is how to ensure that like this is basically how function calling works in programming. But like don't forget that what I said initially, this is the main function, this is the B function, this is the C function. Don't forget that inside the C function there are some variables that are declared, right? So after this function does all its work, it gets popped out of the stack. So all the variables that are declared inside the function, they are all also popped out of the stack. You get the point? So this B also, it's a function. All the variable that is being declared after this is also being done. After the function is being done, it's also popped out of the stack. A is like the main context, right? All the variables inside the main function, like the entry point. When also your program completely run, it's completely popped out of the stack. So this is the stack, right? But now the idea is that not all variables are inside the stack, because stack is kind of limited. So not all variables are inside the stack, right? Because also like when you have all the variables inside the stack, they can't grow. You can't change their size, right? They can't grow. Like so that's why we need heap. We need to be able to grow memory. So if you have something like in JavaScript or C in JavaScript and Python, you have an array. You are increasing the size of the array. The idea is how is it this array particular is not stored on the stack, it's stored on the heap. So then the stack is going to have a pointer to the heap, to that heap, to that memory, to that array, or to that string. You get the point? So like, but if you have something like integer does not change size. Integer, if you have something like integer, you have something like character, you have something like boolean. These are all variables that are stored on the stack. But if you have something like something like array, so in something like Python and JavaScript, they do this for you automatically. They help you to store this variable automatically in the heap. You don't know, but they are storing it on the heap. So you have an array that you can do dot push. You have something that you can do dot pop. You can basically change the size, increase the size. So they are storing all this value on the heap, while all this basic type, it's all stored on the stack, right? So they basically, so now the idea is when you create a memory on the heap, you have to remove the memory. You have to like free the memory so that you can also like keep, because the heap memory is also limited. So that when you free it, other variable can also use it. In something like C++, if you are going to create a memory on the heap, you have to do it yourself. You have to say, oh, I want to create this memory on the heap, right? But in something like Python JavaScript, it's been created automatically. When you declare an array, the array is being created on the heap, so you increase it. So how is the memory being clean on the heap for Python and JavaScript? They use garbage collector, which is basically a software that runs. It's part of the interpreter of Python and JavaScript. It basically keep running. So whenever it goes on the heap using some techniques, if it sees that some values are not being used, it basically removes the value, right? It basically clean up the value. But something like C++, you have to clean the value on the heap yourself. You have to clean the value manually by yourself. So C++, the problem is sometimes you might not free the value. You might be accessing a value that you already freed. You get, and C will not it won't complain. But something like Python JavaScript, this garbage collector that is cleaning the memory on the heap, it's very slow. It goes inside, and maybe the slow is something that you can't see, but like there's some critical software that we don't want that kind of slow. So the garbage collector keep running. It goes into the heap. It goes into the heap. Look for the memory that is not working. It's delete it. It's free them, right? So just understand that there are some memory that are stored on the heap. There are some memory that are stored on the heap memory. There are some memory that are stored on the heap. There are some memory that are stored on the stack. And so whenever you see if you are not from C++, how are you able to like understand memory from the heap and from the stack? So like whenever you have any variable that are kind of like you can change their size, most probably they are stored on the heap. Like if you can change their size, most probably they are stored on the heap. But if I cannot change their size, like int, if you have int 5, like if you have int of like 5 is equal to something, you can't change. You can't. I don't know. Like you can't change the size, right? But if you have an array, you can append to it. You can delete from it. So that's if you have a string in Python and JavaScript, they are all stored on the heap. They are not stored on the what? They are not stored on the stack. So you have to understand that. But, so for something like C++, because in JavaScript and Python they take care of it in all these languages, all these like languages using the garbage collector, they take care of it for you, right? But for something like C++, you have to manually like allocate the memory. You have to delete the memory, and if you don't delete the memory, there will be problems. So those are the problems that that something like Rust comes to fix, right? Those are the problems that something like Rust come to fix using ownership. So maybe it's something I also need to like keep looking more, but like you have to kind of know that like heap and stack, all the basic data type like integer, boolean, they are all stored on the stack. But like if you have something that are complex data type like something like object in JavaScript, it's stored on the heap. Dictionary, because these things are something that grow. You can remove value from the object and you can remove those values. But in heap, in C++, you have to manually declare this variable. But in in JavaScript and Python, you don't need to do that. It automatically does it for you. The reason why you need to know this is that when you're coming to Rust, we are coming to C. It's very important. Like it's very core to the project. It's very core. Like even after this class, you can check it out. Heap and stack. So it's because I've heard it many times, so that's why I'm able to like understand it. Like, but this is like this is very simple. This is like how it works. So this is how it works. So now the idea of Rust is very simple. So we are not talking about heap where in C they have to manually allocate it by themselves and free it. So in Rust it says that and the problem with Python is that Python JavaScript, it's using garbage collector to free the heap. It's using garbage collector, and garbage collector is also a software. It's slow. We want to write very fast softwares, right? So what Rust now does is that instead of the memory, very simple. If you have a memory in the heap, when you declare a variable, that variable is pointing to a memory in the heap, right? Like when you declare a variable, you declare a variable to be pointing on the heap. For something like Python JavaScript, when you declare a dictionary, you declare an array. you don't know it. You don't know that it's storing the memory on the heap, but it's actually doing that. When you declare a string, it's putting the memory on the heap. For something like C++, you have to do it by yourself. But Python, JavaScript, it's doing it. It's not. It's doing it automatically for you. So when you put the memory on the heap, so for in Rust says that if you put the memory on the heap, immediately the memory go out of scope. I think we all understand scope. Like scope is just like where you can access a variable, right? So if you have something like a function, so if you have let a be equals to 5, range. Sinan, you were saying something. Okay, so when you have something like a scope, like you see this a value, you can't access it here. You can't access the value of a. You can't say I want to print a here. Like you can't print a. Scope is like a range. Yeah, exactly. So some sort of like the range of space where you can access a variable, right? So the range, like which particular place, like which particular region can you access a variable, right? So this particular variable you can access it from here. Like this is the range. Like you can access it only inside this function. You can't access it here, right? So that is like scope. So what Ross is now saying is that for all the so okay, now let's now talk about in Rust what are things that are allocated on the heap. So when you have something like this is allocated on the heap. So when you have something like all the basic type, like if you have integer, when you have something like u32 boolean, so let's talk about it. Boolean, u32 boolean array boolean, u32 boolean array. You can also all these float, they are all stored in the stack. They are all stored in the stack. But when you have something like string in Rust, this string is stored in where? In the heap. You have to understand that this string is stored in the what? In the heap. So the other now is that, but you know that when you store something on the heap, you have to free the memory. So you have to free the memory. How do you free the memory? Why is this string allocated on the heap? Because you can basically like increase the size of this string. You can now say let x dot push string push. This is a particular function with string. You can basically say hello world, right? You can basically increase so we can't mutate, so we have to put mute. So what are you saying? You're not saying that s is hello, but like increase the size. So for you to have a growable memory, you put it on the heap. So that's one of the basic reasons why s is being allocated on the heap. So from the question now is that when you allocate something on the memory on the heap, if it is from Python or JavaScript, you don't have to worry. The garbage collector is doing it for you. But if it is something like Rust, if it is something like C++, you have to manually go there and free it and say, free this particular. So in C++, you have to basically say free the s, right? You have to basically free the memory, right? So that's how you do it in C and Python and JavaScript. But in Rust, what Rust is telling you is that immediately a variable move out of scope, immediately you can't, like the range where you can access a variable, immediately you can't access it again. That variable, instead of having to manually like free the memory on the heap, so there is a particular trait which is being which is done, which is like for every variable in Rust, there is a particular trait called drop trait. So immediately a variable go out of scope, a trait function is being called on that variable to drop the memory. You get the point? So it's like when something, so they now kind of tied the heap memory to the scope. So when a variable go out of scope, automatically, like the compiler, there's no need for any garbage collector to keep coming around and looking for variable to a memory that is not being used again and clean the memory. No, there's no need for garbage collector to do that. In Rust, immediately a variable is being called. Immediately a variable go out of scope. Immediately a variable go out of scope, drop the memory of the variable. Immediately a variable go out of scope, so it's basically drop it. So you don't need you don't need the compiler, you don't need the garbage collector to go inside the and start looking for some unused variable. You don't need to manually free it. So because we are human, we might forget that we already feel something. What Rust does is that immediately a variable go out of scope, drop the variable. Immediately a variable go out of scope, drop it. Can you all understand now? That's the idea of how Rust are kind of do the work of memory, do all the memory in the heap. Like that is how it solves the memory in the heap. It's very simple. There are some variable declared on the start, there are some variable declared on the heap. Normally if you declare a variable on the heap, you have to free it. You have to free the memory. So but something like C++, you have to manually free it. Sometimes you are human, you forget that you have to free it. You do some, or you free it 2 times, or you access the memory that you already free. This can create security vulnerability. But for something like Python or JavaScript, you don't have to free it manually yourself. The garbage collector is freeing it for you. But the problem with the garbage collector is very slow. This is why JavaScript and Python, they are very, very slow languages, right? So but something like Rust, it says that immediately a variable go out of scope, just drop the it's a very unique something. Immediately something go out of scope, just drop it, just drop the value. Like since it's kind of logical, like because if something is out of scope, like since you can't access that thing again, so it means we are not using it again. Just drop the memory. Like why do we need to like use the memory again? Just drop it. That's how the memory allocation works in Rust. So I hope you kind of get the idea. Do we get the idea? Maybe little. Yeah, exactly. So now like one important thing about so that's like how memory works. So now one very important thing now that which we can talk about before, which is about borrowing and moving a value. So let's say let x is equals to 5, right? Let x is equals to 5. So let y equals to x. So now see for a simple type, this is integer. For a simple type integer and x, you can basically print both of them now, right? And say x, you can say x. Yeah, let's print both of them, x and y. And this is going to work. This is what's going to work. You see, we can see 5 and 3. So what basically happened is that there is copy, there's a something that is called copy, there's something that is called move. For simple type, so that's why you have to understand the difference between simple type and complex type. So, but like I think a way to understand simple type is these are types that you can't change the value. You can change the value, like they can't grow, it's not growable. So for something like x, like this, the x which is like u32 here, it's always u32. Though you can change through shadowing, you can change the type, right? But like it's not that it's the memory is growing, like where you assign the 5 is growing. U32, it's always like 32 bytes, right? It's always 32 bits, 4 bytes. So you can't change the memory. But if you remember earlier, like when we created a string, when you created a string of right, when you created this particular string, we are able to increase the size of the string, right? It means we are growing the value. Maybe the size of the string before it's this particular size US. So maybe I think for each character is like 4 bytes or something. So this is like 8 bytes. Is it 4 bytes? I think it's 4 bytes in Europe. Like each character is 4 bytes. So we have this U. Let's say we now grow it to like name dot. We now say name dot push str. Then maybe man. So you see that we already grow the size now from instead of U30. We say it's 8 bytes now. It's probably like maybe 4 times 5. That's like probably 20 bytes now. Like it's now 20 bytes. So we change the size, we grow it. So now, very simply, when you have something that you can't grow, a very simple type, when you say this is what I want to say. When you say let x is equal to 5, let x let's print both of them, of course. Let x equals to 5. Let me delete these two. This is very important. So let x equals to 5, let y equals to x. You can actually print both of them. You can what? Print both of them, and it's going to work. As I said earlier, where is it? Print, where is the printing? Is it printing? Yeah, it's printing 5 and 5, right? So you see, the other is x is equals to 5, y is equals to x. It's actually copying the value of x. It's copying it into y, right? So this is how it works. This is how, no problem. This is how it works in other language. X equals to 5, let y equals to x. Copy the value of x, copy into the y. But now in Rust, let's now say we have let's name, which is a string. Yeah, let's say it's string. This is the string value. String dot from shades Usman, right? So now if you now create another string, let name2 equals to name. It's fine, but now let's say we now want to print name. We now want to print the value of name. Yeah. What's going to happen is that the compiler is going to complain. The compiler is going to complain, because see, this is okay for simple type, but for something like a type that is being allocated on the heap that can grow. The compiler is not going to, we have a name here. The compiler is not going to copy the value of name and copy it for name2 also. It's going to basically delete this name, it's going to delete the name and let this name to point to where name is pointed to on the heap, because this name is actually pointed to a particular memory section in the heap, right? So it's just pointed to a particular memory section, in the heap. So immediately we say name2 is equals to name1. That's why they said move. So the value of this name is now being moved to name2. So it means that you can't have this name, this first name is not out of scope, not out of scope, but you can't access it again. The value has been moved. The value has been what? Moved. So that is the idea of move. All the memory on the heap, if you assign it again, the value will be what? Moved. The value will be what? Moved instead of copy. For simple type, it's copied. For all this memory on the heap, the value will be what? Moved. So you can't access the name again. So that's why they said there is some law of ownership. There is 3 law of ownership in Rust, which is very important. But so you see, so this copy trait, all the types I already said, it's integer, boolean, character, all the simple type. They all implement copy, they copy it, right? But for something like string, vector, these variables that are being declared on the heap, they take ownership, they move the value, the value is being moved from name1 to name2. So that's why there's now some law of ownership here, which is very important thing that you need to know. So ownership rule, each value in Rust has an owner. So this value is owned by name. There can only be one owner at a time. So you can't have multiple name1, name2 pointing to the same particular value. There can only be one owner at a time. When the owner goes out of scope, the value is dropped. I already said it earlier. When the owner goes out of scope, the value is dropped. So now let me now say another fourth rule, which is that the fourth rule is that when you assign a new variable to a particular other variable, which is being stored in the heap, the value of this name2 will now be the new owner. This name2 will be the what? New owner. The value of this name, what this name is making reference to, pointing to, will now be moved to name2. But the question now is that Ross said there can only be one owner at a time. So this name is the owner of this Usman before. But now, because in Rust you can only have one owner at a time. So when you now assign this name1, name2, what basically is going to happen is the ownership of this name will be given to name2, and you can't have access to this name again. This name is already it doesn't have value again. But I think you can basically now do, if you do mute, let's see if we can do this. So you can basically do string, but you can still assign this again, and if you print name, this is going to work. Should work. So this is going to work. So name is now as another new value. For something like Rust, or for something like C, here now that we are, let's print name here. For something like C, these are the problem with C. It's going to allow you to, don't forget that now, at this, let me just comment this out. At this point, this name 1, this initial name, it doesn't have any value again. It's already give the value to name 2. This is like a dangling pointer. But in something like C, if you print out this name, it's going to get print out, but it's going to print some garbage value because this name is not pointing to this string again, right? So, but in a program like C, it's not going to complain, but Rust is going to complain to you that, oh, you already like if you look at value is already been moved. So borrow of mode value name, like you already moved the value from name to name 2. So that is the idea of what moving, copying, and ownership. Moving, copying, and ownership. For basic type, copy is done, but you can also like instead of moving, you can now do, I think there's a part clone. Yeah, you can now. So the reason why the value is not being copied, like here it's being copied. The reason why the value is not being copied on the heap, it's because it's so expensive. Imagine this is like 30 bytes. This is very simple. It's because it's small or something. Imagine this is some hash map storing some particular larger numbers of values. In something like a very low level stuff, you can't just be wasting memory. So if for all the values that are stored in the heap, if like instead of being moved, they are being copied, it means that you have to create another section on the heap and store them again. So this is very expensive stuff. So Rust does not do it for you, but you can also like tell Rust to do it like manually. Like I think you clone it. So you can now clone it. So what basically this is doing is similar to this. It's basically like creating a name 2, but like a new value now. It's now giving, it's now creating, instead of moving the value from name to name 2, it's creating a value for name 2 also. Like there's a, so name 2 will have a section in the heap of Usman. Name 1 will also have another section, not the same section, different section, right? So that's the idea of borrowing, ownership, and borrowing, ownership. Yeah. So one important thing also that you can also do, instead of cloning or instead of moving the value, you cannot do reference. So this is also another interesting thing. So maybe you are using Usman, but you don't want to like create a new value pointing to, or you don't want to move the value, right? You don't want to move the value because if you assign name 2 to name 1, let me call this name 1. If you assign name 2 to name 1, it means you are moving the value from name 1 to name 2. So you won't be able to access the value of name 1 again. So it's already been moved to name 2. Or if you do clone, it means what you are cloning is that if you clone something now, it means that you are telling the Rust C or something to basically like create a new section in the heap memory and give it to name 2. That sometimes you might actually want to change Usman to something. Maybe I want to add my surname. You might actually want to add your surname. But if you let's say I use clone. Let's say I use clone here. Name 1 dot clone. Right? If I now say name 2 dot push string. Let's say I want to add my surname. Push str. Let's say I want to say this is like I want to add my surname. So I have to put mutate, right? You have to put mute. So let's say you now put this. Let's now do something. Let's print the 2. Name 1. Name 2. Name 1 and name 2. So the other now is that if you now print the 2, you probably be expecting that they should be the same, but they won't be the same. So this is Usman and this is Usman Akinyemi. But that's the idea. So when you clone, it means that you are creating a new section in the memory, right? You are creating a new section in the memory, and name 1 has its own memory, name 2 has its own memory, right? So that's, you have to understand the difference between copy, move, Copy is for like simple type. Move, you basically move the value. Like when you assign a memory that's been allocated on the memory, like you assign on the heap, you assign its value to another thing, it will move the value. You won't be able to access that value again. But like let's say I want to make changes. Let's say I want to make changes. Let's say I want to make changes to, instead of calling this, let's say I want to like let this string, right? Let's say I want to let this string to be able to instead of I want it to print the same thing. I want to make the change in this name one. I want to make it to this name the change from name two. I want to make it in name one also. So instead of, so that's where you call this is what borrowing, right? This is what we call borrowing or reference. So what I'm saying now is that name 2 is just a pointer. It's not the owner of the value. It's just a pointer to this section of the memory where this name 2, like it's basically pointing to name 1. Name 2 is pointing to what? Name 1. It's not pointing to the value. It's very important. It's not because there can only be one owner of a value at a time. So it's not pointing to the value. It's basically pointing to the name 1. You can basically maybe search more about it, pointing to the name 1, but it's basically pointing to the what? Name 1, right? This name 2 is not pointing to the value, it's pointing to the name 1. So doing this, so it basically have access to this particular value. And noted, it's not copying any value. There is no copying going on. So immediately if something happens, if this memory is if this name 1 is out of scope or you can't access it again, then this is going to be this is going to be pointed to different thing, not this. You get the point? So this is like so okay, let's just do it. Like this is a new scope. Let's say I just say I just access this value and I say name 1 is equals to this. You will see one interesting thing, that there will be some found struct. Oh, sorry. No, yeah, name. Why is there should be some error here? Not this is not what I want to do. Name 1, name okay. No, this is not what I want to do. Let me say okay, let's do something. Okay, let's do let me do it like this. Let's see, this is equals to this. Interesting enough. Name 1. Then we have something like this, and we say we have something like this, and we say no. Then we say this is name 1. Then we say name 2 is equals to making reference to name 1, and let's say we're not trying to print name 2. So you see there is some error. So basically now this is what is happening now is that we have this name 2, right? But we also have name 1, which is in a particular scope. This is a block scope, right? So name 1 is being assigned a particular value. Name 2, we now make reference to name 2, like we now make reference of name 1 to name 2, like so this is basically pointing to name 1. But the problem now is that name 1 is out of scope. Like this name 1, don't forget I told you that whenever a value is out of scope, whenever or a variable is out of scope, its value is being dropped. So what basically happening is that, but this name 2 is pointing to name 1, like it's basically pointing to its value, like it's pointing to name 1, but the value of name 1 is already out of scope. Name 1 does not have any value. So what basically, and you want to print name 2 here, what basically happen is that this name 1 does not live long, like its value has already been dropped. It has already been cleared out of the memory. So if you are trying to print it here, there is already a problem. The value has been dropped. So you cannot reference it. So in something like C++, this will be valid, but the problem, it will be valid, but there will be problem. Like it will just be, so this memory, this name 1 has already been cleaned. At the point it gets here, it has already been dropped. Like there is no value to name 1 again. The name 1 has gone out of scope. So this name 2 is just pointing to some random memory, like it's just pointing to garbage values. So if you try to print it here, there will be problem because it's just pointing to garbage value. I don't know if you get that point. I don't know if you are following, but we declare name 2. We have name 1. Name 1 is pointing to a particular memory, and we are not referencing name 1 to name 2. We are not referencing name 1, like, and we have the value in name 2, like the reference of name 1. So basically this name 1 is pointing to string, but oh shit. So it's just very simple. So immediately, okay, let me just summarize it this way. Name 1. So let me summarize this way. In Rust, a particular variable can only have you can only have one owner of a value. Immediately the owner go out of scope, you drop the value. So, but in Rust, if something like string vector, if you create a vector, it's being allocated on the heap, right? So if you now say A is equals to B for something like string, it means you are moving the ownership. So you won't be able to access the B again if you say A is equals to B. If you say A is equals to B, you won't be able to access the value of B again because you already moved the value of B to A, right? So, but now also, like, instead of moving the value, but you also want B to also have access to its value. So what you basically just do is just put at this reference, you put the reference at the back of B and say, oh, assign the value of, so let A point to B, but don't move the value. B is also valid now, but A is not the owner of the B value. Like, there can be two owners at the time. A is just pointing to the reference of B, like it's just pointing to B itself, not the value. The value is on the heap. Okay, don't let me make it complete. But like the value is on the heap, A is just pointing to B, so but not the value itself. B is the one pointing to the value, A is pointing to the B. I think there's a picture here. There's a picture of something like that here. Yeah, we can even sometimes our picture is not that good. Maybe I will have said something similar like this. Maybe this is B, this is A, but this is not. Let me see if there is a better picture or reference. Exactly. This is what I'm trying to say. So this is S1, string 1. String 1 is the one point. This value, this particular memory is on the heap. String 1 is the one pointing to it. S2 that we are trying to define, that we are referencing using this particular sign, it's not pointing to the value, it's just pointing to the string. It's S1 itself, right? So it's not pointing to the value. So immediately you are not able to access. Immediately this S1 go out of scope. You are not pointing to anything again. So this is what is happening. See, this is what is happening here. We have name 1, we have name 2. Name 1 is being created. Let's say this is name 1. It's pointing to a particular value. So this is a particular scope. Don't forget, this name 1 only have the scope in this particular point. So, and in Rust, immediately the scope of a variable end, the value also is being dropped. So it means that at this particular end of this point, right, the value of name 1, the value that it's pointing to is being dropped. So, and you are not trying to print name 2, which is pointing to name 1, but the value has been dropped. So it means that this S1 is now pointing to, just visualize that this thing is not there again. So it's just pointing to this is what we call dangling pointer. It's just pointing to nothing, right? So it's so this is already a garbage now. But in something like C++, it will be allowed. But your program will be running. It will be wrong, like it will be printing garbage. But in Rust said no. If it is already out of scope, you can't access it again. So just have this picture in mind. Whenever you see something like this, it's basically like just visualize something like this. There's a particular one of the memory value. This is pointing to it, but like this reference is not pointing to this particular value. It's pointing to this S itself. So, but it can make changes to this value. So that's that. You can use it to change this value. You can also use it to, like, So that's basically the idea of of ownership, like ownership, borrowing, and
Lifetime.
yeah. You should go to lifetime, Abby, and quickly complete.
This is also lifetime, right?
Yeah, I think the next. Yeah, let's stop at lifetime. Lifetime. I will just come to lifetime. Oh, it's
No. I was saying this is all the concept you were explaining. That also lifetime, right?
this is yeah. It because
Like it
yeah.
has scope and borrowing also.
Yeah, lifetime is attached to borrowing. Like if you understand this, it will be easy for you to understand lifetime, right? So I mean, right now this name to now have a lifetime, right? Yeah, it's exactly we can say
Like the name one.
yeah,
The
yeah.
name one, Miss Lifetime is finished after the scope. So that's why we are like the name two. That's why name two is pointing to a dangling pointer to avoid. Right.
Lifetime. So
Okay.
yeah, you can if you understand it like that,
And
that makes sense. But name one does not really have a lifetime. What is lifetime according to the Rust? But this is another crazy thing. So, but like I don't know, but like this is if I'm going to like understand like explain lifetime to people, I'll probably explain it in if you say if you check what is lifetime in Rust according to the Rust guys. According to the Rust guys, maybe we can just so what is definition of see, I think we can talk about lifetime now. So lifetime. Okay, where's the definition? If when you understand the definition, because name one does not have lifetime actually. What lifetime? Where's the definition, bro? Okay, exactly. See, they said lifetimes are named region of code that a reference must be valid for. A reference. So if something is not a reference, like this is the one that is like this name too is actually the reference, like the one that has the reference value, right? So this is like the reference, right? This name two is the reference. This name one is not a reference. This name one variable, it's not a reference because see, if you are going to declare something like name two right now, like if you are going to look at it, if let's say we didn't declare it here, so if you want to declare name two here, we say let name two be something like this, right? I will just to so now name two is the one that is the reference. Is what is the reference? Is the one that has lifetime. According to the definition, you cannot have it has to be reference. Is a name of a code is a named region of a code that a reference must be valid for. It's a name code of name region of a code that a reference must be valid for. So a reference, this is the one that is reference. Name one is not a reference, it's a variable. It's a variable that has a value itself. This is the reference. So it's a region of code that a value must be valid for. So now if you try to like now access let's go back to the initial part of the code. Now this is name two is a reference, but here name two is also a reference, but you are trying to print it out, but it's not valid here. Don't forget. So if you want, like what you are not saying that the name two should have like the lifetime from 1, 2, 3, or like this part from year to year, right? Like from the lifetime should be here, but the idea is it's not valid now. That is the problem. It's not because the lifetime goes out of scope or something. It's because the lifetime is not valid. Why is the lifetime not valid? Because it's pointing to a memory that has been dropped. Like don't forget that at this point in this particular section of area, like if you print name here, if you you do yy and print it here. If you print the name here, let's remove. So if you print name here, it will be valid. There won't be any error. Like it's going to work. Usman, right? It's work. These are just warnings. So it's going to work here. So it means so now right now the lifetime of name two is from year to year. And according to the definition, the region where it must be valid. At this point, it is valid. So the compiler will not complain because it's valid. Why is it valid? because name one that this name 2 is referencing, the value is not out of scope yet. But immediately you put the name 2 here, you want to print it here. Name 2 here is here, it's here, it's this is its lifetime. But the question is the lifetime valid at this point? It's not valid. That's why the compiler complained, because it's pointed to dangling reference. So if you want to understand this, my own approach of understanding lifetime, there is this particular video on YouTube which I checked, because the way the Rust books, the way they explain lifetime is kind of not that good. Lifetime in Rust. So you can check it out. So this basically like explain lifetime for you.
And to do that,
So
eventually though, to me,
the way-
points to X,
so
this is invalid code.
if you listen
R
to
clearly
what I
tries to
say-
explain this error X, and because an issue changed, R still lives. A lifetime is something else. The rest of the
Exactly. So
code where
what
certain
Ross said-
variables can be accessed.
What Ross said about lifetime is not even like according to their definition. So it's
A lifetime is something else. The Rustonomicon defines them as
This is-
named regions of code that a reference must be valid.
Shit. Just check the video. You will understand it more. Like yeah, you will understand it more. But like as I said, like that's just the idea of ownership, referencing, and borrowing. So when you see the idea of reference, S1 is reference. It's referencing this. This is the reference variable, but this is the owner of this. So when this goes out of scope, you can't point to this again, right? So that's just the idea of referencing. I don't know if we should continue, or if there is some particular questions that you want me to like address, or kind of, because it's already 8 p.m. that the stuff already about 2 hours. So is there any specific question or any specific topic that you probably want me to take before like completing? But like I think the other is, if you're able to kind of, so what you should take away from wherever we have done is that you should even if you have not understand yet, go and understand stack and heap. Like just go and watch a lot of videos on stack and heap, then try to understand what variables are stored in the stack, what variables are stored in the heap, right? Then if from here, I think you should be able to understand that in C++, you have to manage the memory on the heap yourself, while in something like JavaScript and Python, the garbage collector is doing it. But Rust said it's different thing. You have to like immediately the variable go out of scope, the value in the heap will be dropped, right? So that's it. So you have to understand. So those are the things. Then you can also come and check the video of lifetime here, because there is also like one particular aspect of lifetime here, where the guy actually explained a very good way of how to like understand how do you understand the lifetime where is it yeah, like I think it's in maybe this particular point. So but the other is, if you understand the concept of borrowing and ownership, you'll be able to understand most of all these things, like, because when it keeps going after it keep getting complex. But like I think if you understand like our idea of borrowing, ownership, reference, you'll be able to understand most of the concepts. So if you guys want like maybe there is any question or particular topic, like maybe that you quickly want us to go through, or maybe or I don't know, because I'm thinking that we should stop there so that everyone can be energized, continue their work and stuff. Sinan.
Yes, Usman, I can hear you.
Yeah, is there anything that you want me to like quickly cover or or say or something?
No, it's okay for me, but are you having another session next week?
See, I don't know if it's depend on you guys, and I also have a study session which I do. If you guys also want to join, though I don't teach, I just study Rust. Like I do it like so just like I don't know your time, so I used to do it on my. I just like so basically what I did is I just study Rust for like 4 hours every day, right? So for like 4 hours every day. So because the idea is see Aki blockchain like they might not be able to teach us everything in like even the Rust videos which they posted was like for 1 hour, and Rust is you can't learn everything in Rust for 1 hour. Even just simple thing that we just did now, we're already using like 2 hours plus. Sure you get so if you're also interested, you can join something like that, something like this. And he also wants me to like come next week and continue. That is definitely fine by me. You get the point. That is definitely fine by me. But I believe that within the time period, you can also like have learned a lot about Rust. You know, and I think that another thing is I'm very available. Whenever you have any problem, you can drop it on the or message me on the Discord. I can just I can just share. I can just I can just what is the question? We can have some personal video like we can have private call where I can explain some concept to you if you're interested. So and
Okay, so no problem. I will chat you up.
yeah, definitely. If you have any issue, just
Okay.
chat me up.
Thank you.
Yeah.
It's actually nice meeting you, bro. I've learned a lot from you.
Oh, wow, interesting.
Thank you.
I mean, I would like to know you more. So, like, I'm also like growing and learning. So,
Okay.
yeah, thank you.
I'll chat you up, bro.
Yeah, definitely.
No problem.
Thank you, guys. Thank you for coming. Maybe we meet next week or wherever it is. Yeah. Thank you. See you. I would like to connect with you guys. So, do connect, right? Yeah. Thank you, guys. See you guys. Yeah, we can end now.
Okay, have a nice day, Usman. Nice days, nights already night.
Yeah, and you too.